Hello, and thank you for using TickBoom. A student has sent through this question and they've asked me to help them specifically with question 3 part D. So we're told to let z equal cos theta plus I sine theta, so that's a complex number. And we're asked to prove a whole bunch of trigonometric identities, and the one in part D is to show cot4 theta is equal to 4 cot cubed theta minus 4 cot theta, all divided by cot to the 4 theta minus 6 cot squared theta plus 1. And I think looking at this identity by itself, I think it would be quite a challenge to try and prove this starting from z equal to cos theta plus I sine theta. But I think, like with most questions that are broken up into parts, I think whoever wrote this question is trying to guide students to this final result by getting them to do the results in part A, B, and C first. And in particular, I look at the result in part C, which is about tan 4 theta, and knowing that tan and cot are just the inverse of each other, and looking at the result for tan theta and seeing that it's got the same kind of exponents, we've got a tan cubed, a tan squared, and a tan to the 4, you can kind of almost instinctively see that there's going to be a relationship between these two. So I think, whilst I'm only going to focus on part D here, what you would probably see working through all these parts is that you'd work out the cos 4 theta result and the sine 4 theta result, and you'd probably make use of that to get to the tan 4 theta result. And now what I'll do is I'll use this tan 4 theta result to get to the cot 4 theta result. So I'll start just by writing what we've been asked to prove. So we're being asked to prove that cot 4 theta is equal to 4 cot cubed theta minus 4 cot theta, all divided by cot to the 4 theta minus 6 cot squared theta plus 1. And I think the natural place to start is from part C, where we've already would have worked out that tan 4 theta is equal to 4 tan theta minus 4 tan cubed theta over 1 minus 6 tan squared theta plus tan to the 4 theta. So I think knowing that cot 4 theta is equal to 1 over tan 4 theta, I think all we really need to do is take this result and invert it, since we're getting 1 over, and see if we can then simplify it to eventually get to what we're being asked to prove. So cot 4 theta would be equal to 1 minus 6 tan squared theta plus tan to the 4 theta over 4 tan theta minus 4 tan cubed theta. And what we need to do is get all of these tans into cots, and I think just to help avoid mistakes, it's probably helpful to do these one at a time. So if we call the numerator A and the denominator B, let's just evaluate these one at a time to get them into cots. So first, starting with A, that would be equal to 1 minus 6 tan squared theta is the same as 6 on cot squared theta, and tan to the 4th theta would be the same as 1 on cot to the 4th theta. And what I'll do is I'll get all these to have a common denominator. So that would be equal to cot to the 4th theta minus 6 cot squared theta plus 1, all of that on cot to the 4th theta. So that's A. Now if I think about B and how we can simplify that, B would be equal to 4 on cot theta minus 4 on cot cubed theta. And what I'd like to do is get all of this to have the common denominator of cot to the 4 theta, because that's going to help things cancel later. So that would be 4 cot cubed theta minus 4 cot theta all over cot to the 4 theta. So now we can come back to our cot4 theta result, and we'll get cot4 theta is equal to, and I'll put in A, so that's cot to the 4 theta minus 6 cot squared theta plus 1 all over cot to the 4 theta divided by B, which is the same as multiplying by 1 over B. So I can just reverse this, so I'll get cot to the 4 theta over 4 cot cubed theta minus 4 cot theta. These cancel, and we get our final result of cot to the 4 theta minus 6 cot squared theta plus 1 over 4 cot cubed theta minus 4 cot theta. So that's what I think the result should be. I don't think I've made a mistake in any of this. But interestingly, what I've got is the inverse of what we're trying to prove. So the question becomes, who's made the mistake here? Is the textbook wrong? Have they simply sent students on a wild goose chase by asking them to prove something that's incorrect? Or have I made a mistake? Now, the beauty of trigonometric identities like this is we can use our calculator to check. So I can just pick an example. I might pick, let's just pick theta equals 50 degrees. And we can then just work out cot4 theta, the left-hand side, and work out the right-hand side and see, well, which one is correct. So if I choose a theta of 50, then that means 4 theta is going to be 200 degrees. So let's just do that on our calculator now. So if I do 200 degrees, I'll first work out tan of that. And then I'll get the inverse. So I'm going to get cot4 theta is equal to 2.747 and so on. So that's the left hand side. Now let's see what do we get here. So if I just work out tan theta, so tan of 50, and I'll store that in 1, and I'll just check that's worked, yeah. So now let's do, let's do that and get the inverse, and actually that's what I want to store. So that's cot theta that I've just stored. So now we want cot theta to the power of 4 minus 6 times cot theta squared plus 1, and all of that divided by 4 times cot theta to the power of 3 minus 4 times cot theta, and that gets us, this here is 2.747 and so on. So I have a feeling I'm correct, but let's just double check and see. Well, we almost know it's just the inverse. So if I inverse that, it gets 0.3639 and so on, which is clearly not correct. The left-hand side and right-hand side aren't equal. So I'm 99.9% confident that this is the correct answer, and that the textbook, whatever textbook it was, has a mistake. So unfortunately, I think a lot of students who are facing this question, they might be struggling not because they've made a mistake, but because they've been sent on a wild goose chase, which I think is unfortunate. But for any students who do find themselves in that predicament, whether on this question or other questions, when trigonometry is involved, I think you can help prove who ultimately is correct by just taking an example or two, and hopefully that'll settle any dispute. So hopefully that's all made sense, and you've been able to follow along. I think at the end of the day, this part D became relatively simple because part C had already been proven. So really, I think all the hard work of this question was done in part A, B, and C, which meant part D kind of just fell out of the wash. I think it would have been a much harder thing to try and prove from nothing, because you would probably then have to work out yourself to think about proving the identities in A and B and C. So you'd probably still get here. It's just that you'd need to somehow have the imagination to go, well, how can I prove these intermediate results to help me get to this final result? So yeah, hopefully you found that helpful, and tick boom.